All right. Hi, everyone. Thanks for taking the time to attend my session. I'll start off by introducing myself. My name is Rana Khalil. I'm the AppSec and training lead at a consulting firm in Qatar. The firm is called Malumatiyya, and I joined it a few weeks ago. I have a bachelor's and a master's in computer science, and I'm OSCP certified. Some of you may know me from my online academy and my YouTube channel where I teach web security. So far across all platforms, we have over 21,000 students learning web security, which I think is amazing. In fact, this presentation is a really mini version of a course that's going to come out on my academy in the next month or so. And so to celebrate that and to say thank you for attending my session, at the end of the session, I'm going to provide you guys with a 50% off coupon to my academy, which I believe is the first time I actually provide a discount on my subscription model that came out recently. All right, that is enough about me. Let's dive into the topic. So the agenda for today is to answer 3 questions. The first one is, what are JSON Web Tokens, or in short, JWTs? So we're going to look at what JSON Web Tokens are, their format, and how they're used for session management and authorization. Then we'll move on to discuss how to find and exploit vulnerabilities in the way JSON Web Tokens have been configured and implemented. And then we'll end with how to secure your applications against these types of attacks. So we'll start off with the first topic, which is, what are JSON Web Tokens? Now, before we define that, we need to kind of understand how session management works in applications, and we'll do that using an example. So imagine you have a user. I hope you could see my mouse, but imagine you have a user and a web application. The user wants to log into this web application in order to gain access to his banking information. And so the way that happens is the user visits the login endpoint. He puts in his username and password. The application retrieves that username and password, checks it in the backend database, and if it's correct, it generates a session ID or a session token for the user and saves it in the cookie jar of the user's browser. Now, this session token allows the user to visit subsequent authenticated pages in the application without having to put in his username and password every time the user wants to visit an authenticated page. And so this session token essentially acts as a short-lived password. And just like you want to keep your password secure and that no one can tamper with it, in the same sense, you want to ensure that this session token remains secure. And that responsibility largely falls on the developers of the application and how they configure this session management. And depending on how it's configured, it could potentially introduce major flaws into the application, which we'll see in a bit. Now, how does this relate to JSON Web Tokens? Well, a JSON Web Token is just a session token that is used for session management and authorization. The difference between a JSON Web Token and a classic session token is that it's not randomly generated. So with classic session management, or what we call stateful authentication or stateful session management, you get a randomly generated session token that is usually stored in your cookie jar. And that token acts as your short-lived password for the remainder of the application. Now, with JSON Web Tokens, they're not actually randomly generated. They contain information, and that information, which is your user role, your username, certain information about the user, is what determines the authorization decisions that allow you to access certain resources in the application. And so this token over here, if you decode it, you could actually see its information. It's not meant to be secret. So that's one difference. The second difference is that with JSON Web Tokens, they're called stateless session management or authentication, because the token itself is not actually saved in the backend server, just like with classic sessions. So everything that the application needs in order to determine if you have access to a resource is actually stored in that token itself. And so you might be wondering, well, it's coming from the client side. How is this secure? We'll talk about that in a bit. So the token is made up of three base64 URL encoded parts, each separated by a dot or a full stop. The first one is the header over here. The header contains metadata about the token itself, such as the algorithm that is used to sign the token. And then you have the payload, which contains the actual claims about the user. So for example, the user's name, the user's username, their role, their authorization privileges, and so on. And then the last component is the cryptographic signature of the token. So if we take an example from the lab environment of the Portsmouth Web Security Academy over here, this is the JSON Web Token that you would see if you intercept your request in an intercepting proxy like burp. It's base64 encoded, and just like I said, there are three parts. In this case, they're color coded. The red portion is the header, which contains the key ID and the algorithm that is used to sign the token. And then the second part is the payload, which contains information about the user. So over here, we've got the expiry date of the token, the name of the user, the role of the user, the email of the user, and so on. And then the last portion is the signature of the token. Now, you'll notice over here, all the authorization component of what allows a user to access a resource are stored in the payload over here. And just like I said, this is something that is coming from the client side. And so technically you're allowed to tamper with it, you're allowed to change it, and so on. And so how can this be trusted by the web application? Well, this is where the last component comes along, which is the signature of the token. So the way this works is that when the token is generated by the backend hashes this token and signs it using a key that is only known to the backend. And so every time you send a request with a JSON Web Token, it actually rehashes the JSON Web Token and confirms that the signature, the new signature, is actually equivalent to the signature that came with the token. And if it is, it allows the token to go through because only the backend has access to that key. And so only the backend could make changes to that token. And if it's not, it'll reject the token. Now, this is a great segue into our next section, which is how do you find and exploit JSON Web Token vulnerabilities? Well, majority of the attacks against JSON Web Tokens are attacks that try to somehow bypass that signature component that we just talked about. If you're using a vulnerable library or an outdated library, or the token is configured or implemented incorrectly, there's a ton of attacks that you could potentially perform. Unfortunately, we won't be able to cover all the attacks today just because we're really limited on time, and I want to make sure I leave at least 5 minutes for questions. And so instead, we're going to cover at least the first four vulnerabilities, and then we'll leave the rest for you to either research or it'll come out on my course that will be included both on YouTube and on my academy. And so we'll start off with the first one, which is accepting arbitrary signatures. So the first attack vector is really simple to the point that you wouldn't believe that you could actually find this in real applications, but I've actually found it in one application and I never found it after that, but it's definitely possible, more so in older applications than ones that use more modern libraries. But the attack essentially is that the application does not actually verify the signature of the token. The reason this used to happen is because developers used to confuse the method used to decode the token with the method that is used to verify the signature of the token. And so the developers assumed that if your properly decoding the token, that means it's valid. And so you don't actually need to verify the signature of the token, or they assume that the decode function actually verifies the signature as well. However, it doesn't. It just decodes the token and ensures that the token is in proper format. And so if you look at the original payload over here, this is from the lab environment in the Portswigger Web Security Academy, which is free and available for anyone to play around with. But essentially over here, you could see we've got a token that is supposed to be signed using the RSA algorithm. And it takes in the name of the user, which is Carlos, or the username of the user. Now, based on the username that is inputted in this request over here, or in this JSON Web Token over here, it allows the user to access that specific resource. And so if the application accepts arbitrary signatures, all you really have to do is go into your intercepting proxy like verb, and change, so decode the JSON Web Token and change the username from Carlos to, let's say, administrator, because you want to gain access to the administrator's account. And then the signature is no longer going to be valid. However, the application in the backend is not actually verifying the signature. And so regardless of what changes you make in the JSON Web Token, the application is going to accept the token and will give you access to the resource that is listed over here, which is the administrator. So again, this is probably the simplest attack that you could perform on JSON Web Tokens. I've found it in an application before, but unfortunately, I haven't found it again since then. Another attack is accepting tokens with no signature. So this is called the non-algorithm attack. So for debugging purposes, previous libraries used to allow developers to set the non-algorithm, or had support for the non-algorithm, which meant that the JSON Web Token is not actually signed. And that's because it used to be used for debugging purposes on development environments without any production data. And so it was assumed to be safe. However, if this made it to production, this configuration made it to production, and the application trusted the algorithm that came in a JSON Web Token, which is client supplied input, then the way you could exploit this vulnerability is essentially decode the token that you have, and then change the algorithm from the algorithm that is set by the application, which is in this case the RSA algorithm, and change it to none. Now, this means that the token is not signed, and so you no longer need to provide a signature with the token. And so over here, we change the username to administrator. And since the algorithm is none, all we have to do is remove the signature portion from the JSON Web Token and submit the JSON Web Token. Now, in the backend, if it has support for this algorithm and it actually extracts the algorithm field from the JSON Web Token, it'll see that it's like there's no algorithm, and you don't need to actually sign the token. And so it'll implicitly just trust what is in here and give you access to the resource that you requested over here, which is the administrator's account. This configuration is no longer, I believe in majority of the recent libraries or modern libraries, is no longer possible, or you'd have to actually implement it, configure it yourself to make it possible. And so this type of attack, I doubt you'll see in modern applications, but it used to happen before. All right, another attack vector is brute forcible key. So this attack occurs when you're using symmetric encryption or symmetric signing. So with JSON Web Tokens, you have the ability to either use asymmetric signing algorithms or symmetric signing algorithms. With asymmetric signing algorithms, you don't have control over what the secret key is, in the sense that you can't just pick it yourself. However, with symmetric algorithms, you can actually pick the secret key yourself. And so just like you would choose a password, let's say if you set your password to password, in the same sense, you could choose the symmetric key to be password for your signing algorithm. And so if you use a weak, easily brute forceable key, then an attacker could potentially compromise your entire authorization and authentication mechanism. And the way that works is all the attacker has to do is have an account on the system, generate a JSON Web Token, and then take that JSON Web Token and pass it into a password cracker, such as Hashcat. What that does is it attempts to brute force or do a dictionary attack on a predefined list of words that could potentially be the password. And then if it identifies the same signature, that means it found the correct secret key. In this case over here, this is also from the lab environment, and I believe the secret key that was used to sign the JSON Web Token was just literally the word secret. And so now that we know what the secret key is, we could alter the token as much as we want and generate any token that we want. We'll sign it with the secret key, and when the backend receives that token, it will verify the signature. And since we're using the same secret key, the signature verification will pass. And so we'll be able to access whatever resource we requested. And again, in this case, we request access to the administrator account. And since we're able to actually generate a valid JSON Web Token for an administrator account, the application allows us to access that administrator account. All right, the last one we're going to discuss today is injecting a self-signed JWT via the JWK parameter. So the JSON Web Key, or in short JWK, provides an embedded JSON object representing the key. So this is an optional header parameter, which allows you to embed your public key directly within the token itself in the JWK parameter right over here. Now, if the server was misconfigured, sometimes it allows you to embed it directly, and then it'll implicitly trust that JWK that you put in there. And so this way, you could put in your own key in the header of the token, and then sign your entire job with that key. And when the application comes to verify the signature, it'll pull your key from over here. It'll check it'll check the signature of the token, and since the signature is going to be valid because you signed it with that key, it'll allow the token to pass through, and it'll give you access to the resource that you requested. And so again, this is another exercise that you could play around with in your free time. It's on the Web Security Academy, which is a free online resource. In this lab over here, we obtain a token using our regular user account, Carlos, and then we conduct this attack. So we first generate a new RSA key, which can be easily generated using a JWT editor extension in Burp. And then from there, once we generate the new RSA key, we add the JWK parameter in the header of the request, of the JSON Web Token, and then we sign the token using that specific key that we just generated, and then we send the request. And from there, because we changed our JSON Web Token to gain access to the administrator's account, and it's signed using the key that the application is going to pull down directly from the JSON Web Token, the verification will pass, and it'll allow us to gain access to the administrator's account. And that's pretty much it for this attack. It might seem a little bit complex, but these attacks can be performed with a matter of seconds, especially with the extensions that we have available in Burp right now. And so you don't necessarily have to do it manually. And so this is a pretty low effort attack that will allow for significant damage in terms of compromising the entire authorization mechanism of the application. All right, that is it for different attack vectors on how to exploit JSON Web Tokens. Again, there are so many more attack vectors out there. However, I can see we're already running short on time, and I want to leave 5 minutes for questions. And so we're going to move on to the next section, which is how to prevent JSON Web Token attacks, or how to secure your JSON Web Tokens. The first thing that you need to do is use an up-to-date library for handling JWTs and ensure your developers fully understand its functionality and any associated security implications. So I mentioned the non-algorithm attack. There's also an algorithm confusion attack that we didn't talk about, and so on. All of these used to be possible in previous outdated libraries. Right now, it's either impossible or very hard. You would have to make the library and secure yourself. And so it's really important that you always use an up-to-date library that is secure by default. And also ensure that when you're checking the signature, or when you're performing any actions on the JSON Web Token, that you actually properly understand what those functions and what that functionality performs. Next, always ensure that the signature of the JWT is properly verified. We talked about a specific attack vector that I've actually seen in a real-world application where the JWT signature was not actually validated, and so you could technically tamper with the token as much as you want, and the application still accepted it. Next, you should enforce a strict whitelist of permitted hosts for the JKU header. So we talked about the JWK header. We haven't talked about the JKU header. It stands for JSON Web Key Set URL. It essentially functions really similar to the JWK header, except it retrieves the key from a URL that you provide. And so if you're able to enter that value and the application will implicitly trust it coming from the client side, you could just store your key in your attacker-controlled server, call it from there, and sign the token using that key and perform the exact same attack vector as you would with the JWK parameter header. You should also ensure that the KID header parameter is not vulnerable to path traversal or injection vulnerabilities. We also didn't get a chance to talk about that one, but the idea over here is you're also bypassing the signing mechanism by by performing injection attacks that allow you to sign the token with a file that you already know the content of, and so you're capable of knowing the essentially the key that was used to sign the JSON Web Token. There are exercises for all of these on the Web Security Academy and will be available on my course as well. And so there's plenty of free online resources for you to learn anything that we didn't get time to learn today. So this is how you would secure JSON Web Tokens. There's also best practices to ensure the security of your JWTs. The first one is to use asymmetric algorithms over symmetric algorithms whenever possible. So this one's a bit controversial because symmetric algorithms are safe and they're secure if they're used properly. However, you sometimes cannot control human error. And if someone decides to use a default key, or a key that is just copy-pasted from Stack Overflow, or a key that is weak and can be easily brute forceable, then an attacker could compromise your entire authorization mechanism. And so that's why I always recommend that, if possible, use an asymmetric algorithm where you do not have control over you don't get to choose what the secret key is. And so by default, you're not vulnerable to that specific attack. Next, set a short expiration time for tokens to limit the duration of their validity. So by default, JSON Web Tokens do not actually expire on the server side when you log out. And so it's important that you decrease the expiration time to as low as possible to decrease the window of time that an attacker could compromise your session. Of course, if you need more time, there is a mechanism called refresh tokens that you could use, which allows you to securely refresh your JSON Web Tokens to increase their expiration limit. And then last but not least, avoid sending tokens in URL parameters where possible. So just like you wouldn't include passwords or any sensitive information in places which could potentially be compromised, such as URLs, you shouldn't include tokens as well, because they essentially work as short-lived passwords for your session. And that is it for how to prevent JSON Web Tokens. I did promise you a coupon to my academy. And so if you're interested in learning more about this topic or any of the other 15 plus courses that are available on my academy, the coupon code is APISEC half off to get half off of the 6-month and the 1-year subscription. I'll include that in the comments in a bit. And that is it for my presentation. I hope I didn't run out of time.
You did not run out of time, but we are going to run out because there's so many questions here, Rana. Golly, what are we going to, let's pick a couple of here. Wolfram always has some fascinating ones. So I don't even understand Wolfram's questions. So that's how good they are. Full or partial encryption. Can you address this question?
So full or partial encryption of access tokens, ID tokens would be nice to, can we put the question back?
Oh, sorry.
To not expose sensitive data to the client app. So JSON Web Tokens shouldn't include any sensitive data. But if you absolutely need to include sensitive data, yes, there is an option to encrypt your tokens. They also make them much harder to tamper with. However, just signing your tokens should be more than enough to keep them secure. Sensitive data should not be included. It's best practice not to include sensitive data in a JSON Web Token.
All right, let's see if we can cram a few more here before we get Bill up. Let's see. Is it secure to use OAuth over JWT?
JWT can be used with OAuth. So it's not like one or the other.
All right. How about this one from Shaquille? Constrained tokens.
I'm not sure what that is. So unfortunately, no, I can't shed some light on that. I'll have to look into that.
No worries. Let's see. Let me get one more in here before we break. All right, this is a simple one. Hopefully this will be quick.
Oh, no, absolutely not. You could find it in all major frameworks. So yeah, no, like you'll see it for Java, for Python, for all the major frameworks and major programming languages.
Wonderful. Well, I think we'll wrap it up there, Rana. So again, thank you. These authentication topics are always so interesting. People have tons and tons of questions. So your resources are invaluable. I highly recommend everyone go check out her academy. Thank you for offering the discount to the APISEC community. And I'm sure we'll be seeing you again, Rana, and congratulations on your new move and new adventure. So wishing you all the best.
Thank you so much. And thank you for having me. This was a lot of fun.